Hello, this is Cody Jackson for Codemom. We are continuing our Python series, and we're going to take a look at the Python data types. Just a blatant plug, if you're looking for more information about Python, here's a couple of books that I've written. I don't think I've mentioned it yet, but everything that we are covering in this video series is actually coming from the Learn Programming in Python with Cody Jackson book. So if you want more details about what I'm talking about, that is one alternative, because basically the information you see in the video is a consolidated version of what I put into that book. Not saying that there aren't alternatives out there. Feel free to use whatever is best for you. I'm just kind of putting that out there for anybody who wants more information specifically about what I am talking about. Moving on, we're going to take a sidestep and we're going to talk about code structure within Python before we actually jump into the data types. So I had talked previously about how white space matters when you're using Python. And so for this, I just got a screenshot of a program that I had written a couple of years ago. And I just want to show that this is a typical example of a Python program, how it's formatted. So your main class or function or whatever it is that you're going to do, everything that you're going to do is going to start on the left, and then if it's part of that same block of code, then it's going to be indented under it. So you see here we've defined a class, and everything below it is part of that class. So here we have a docstring, which just gives you some basic information about what the class does, and then we have two methods, which are functions that apply to this particular class. We have an initialization method that just pre-populates a instance of the class. And don't worry if this doesn't make any sense to you. We will talk about object-oriented programming and classes in a future video. Just push the I believe button and continue listening. So we have the initialization method, and then we have a representation method, which, like it says here in the docstring, just returns a string representation of the bicycle object. So we are telling Python how we want a text string to be given back to us if we call the bicycle object. So it's just going to tell us the model, the weight, and the cost. So this same stuff that we identified up in the initialization method. So also note that while the two definitions of the methods are indented in one line, the block of code that is part of those methods right here is all lined up as well. If you had other conditionals like if else, or you had other loops or anything like that, those would all have their associated code indented with them. If you still don't understand what I'm talking about, don't worry about it. We'll see it more and more as we go through more code examples. Moving on, we're actually going to jump into the Python data types. First, we want to talk about numbers. So in Python, I'm going to maximize the amount of number space you can use. What I mean is, right here where it says normal integers, maximum length determined by the operating system. So that's basically a holdover of how C, the C language, would deal with numbers, is that there's a certain number of digits that you can have in a number before your program crashes or you have some other errors. Python integers, as you can see here, the maximum length is based off of the available memory. So it doesn't care what the operating system says a maximum number is. As long as you've got the space for it in your computer, Python's going to use that space. Generally speaking, you don't need to worry about how big of a number you're using. Python's just going to accommodate it for you. Python also has floating point numbers, which are basically just numbers with a decimal in them. Now, the decimal doesn't have to be shown. We have 3.14 here, so we have a decimal showing here, but you can also use scientific notation if you're familiar with that. So you can have 3e8, which basically just says 3 exponent 8, or 3 to the 8th power. Same thing with this one. 2e negative 4 is 2 to the negative 4th power. Octal starts with a 0. Octal is not very common anymore. It used to be common in days past. You probably won't ever see it, but it is available if your program requires it. Hexadecimal is also available, and hexadecimal is very common if you are working with assembly language or shell scripts or any sort of low-level programming that's going to be directly interacting with the central processing unit or other memory locations and things like that. And then finally, complex numbers coming from your math, so those are going to be your imaginary numbers, are supported as well. You can have lowercase j, uppercase j. It doesn't use an I. If you're going to use a complex number, your imaginary portion is going to be signified by a j. You can use integers. You can use floating point numbers. So we talked about this briefly. Python integers are not limited by the operating system like C, but by memory. And so the type of operating system that you have, 16-bit, 32-bit, 64-bit, it doesn't matter. Python will accommodate whatever limitations that operating system has, so you don't have to think about it. Your numeric operators, such as plus, minus, greater than, less than, are also supported, and they're similar to other languages. And generally speaking, they function just like they do in math. Speaking of math, there are a number of different math functions available to you from the built-in as well as third-party libraries. The math library provides a lot of math-specific functions such as sine, cosine, powers. Random provides a variety of different random number generation schemes. Your order of precedence when it comes to the operators, so you do a times operation before you do a plus operation from math. It's the same as math, but it is encouraged to use parentheses just so that whoever is reading your source code understands what your intentions are. Especially as your formulas start getting more and more complex, it can be difficult for you to determine what is going to be happening first, because how you do your code in Python or pretty much any language is really single line by single line. It's not stacked like you see in regular math, and so having your parentheses in there helps you to formulate in your mind what that order of operations is, because you can't see it in a regular mathematical formula. Mixing floats and integers results in a float value. So if you have a decimal and a integer, your integer is going to be upgraded to a float value. So instead of an integer of 3, you would have 3.0. And that is just so when you do your operations with those mixed numbers, you get the most accurate value that's returned. So whatever the remainder is, the dot 5 or whatever your leftover is going to be more accurate that way. So that's about it for numbers. Numbers are pretty basic, and unless you're really doing a lot of mathematic type things, you're not going to have to worry or think about what the numbers are doing in your code. So we're going to jump ahead to strings, and text strings are very common in any code really, because at some point you have to interact with the user, or you're going to be working with text to data on a server or something like that. So in Python, A text string is just normal text, and that includes numbers, characters, and symbols. While a number may have a mathematical value, once you convert it to a string, it becomes text. You can no longer do your mathematical calculations with it. Text strings cannot be changed in place. What that means is if you have a text string, a sentence, and you want to make a change to it, whether add new characters to it, new words to it, or do some sort of a change to it, the original text string doesn't change. You're basically making a copy of it and then adding those changes to that copy. We talked previously, you can use double or single quote marks when you're working with strings. If you're just creating a initial string variable, but you're not going to populate it with any characters, then you can just use an empty string. So basically quote quote with nothing in between, not even an empty space, and that sets that variable to be an empty string. The plus and the star operators are overloaded in Python, which means while they normally do mathematic operations, Python is intelligent enough to realize that you are working with text strings, and so it will change those mathematical operations into text operations, allowing you to work with text strings. If you want to combine strings, so like if you want to add multiple words together to make a sentence, then you just use the plus symbol. You're just adding them together, literally. You can repeat a text string by using the asterisk or the star symbol. So if you had the word spam *3, it would print out spam, spam, spam. And we'll show this in a live example coming up. To combine a text string with a number, you have to explicitly tell Python that you are converting the number to a string. I said this before. Once a number becomes a string, then it is no longer a number. It is a text value, and you can no longer do any sort of mathematical or arithmetic operations with it. So we're going to jump out of the presentation for a bit and just talk about what we have talked about already. We're going to demonstrate what we've talked about already. So if we want to combine two strings together, concatenation, then we use the plus operator. So if we have a simple sentence first string and we want to add it to another string, then we just use the plus symbol in here, and it combines first string and second string together to make a whole new sentence for us. Notice that it did not add a space. It literally just takes what we gave it and uses it over again. If we want to add a space, we can do that manually by putting it at the end of the first sentence, and you'll see that it provides that space in there. So it basically takes the raw text that we've done and just combines it all together. It concatenates it or adds them together. So that's what the plus operator does. If you want to use the same word multiple times, or the same text string, then you can use the times operator. And you see that in this case we have the word knee, and it's printed it 4 times. So those are the two primary operators that you have for text strings. If you want to make a empty text string, then you can say string equals double quotes, and there's nothing there. So if we print the string that we just created, you'll see that nothing is returned. It is completely blank. If you want to add a number with a string, if you try to do it without converting the number to a string, you're going to get an error, and this error says can only concatenate string to string, not integer. So it's basically saying you can't do anything with this number until you convert it to a string. So to do that, it's very easy in Python. You can either use quotes and explicitly state that this is a string value, or you can convert it to a string using the string method. So either way works for you. You can put the value in quotes, or you can wrap it in the string function and it will do it for you. Moving back to the presentation, to iterate over a text string, basically if you have a sentence and you want to sequentially go over it and do something with those characters within the string, then you use a for loop. We have not talked about for loops yet, so don't worry if that doesn't make sense to you. Just recognize that strings have built-in functionality for iteration processing, or to put it another way, strings have the ability to sequentially go over all of the characters within the string and do something with them, whatever you determine that something to be. Indexing. To access a specific character within a string of characters, then you tell Python what that position is. So starting from the left, the first position is going to be 0. So if you have a text string of ABC and you count it, it's 0, 1, 2. Python, like many other languages, starts counting at 0 and goes to 9. That gives you 10 values. The reason for that is basically to save memory. You can get 10 values, but you don't have to have that tens column. If you remember back to your basic arithmetic, you have your ones column, your tens column, your hundreds column. You can save memory by not having that extra column. If you're counting from the right, you can go backwards, but it does not start at 0. 0 is already used. So the very end value within a text string is -1. The one to the left of it is -2, -3, and so on. And we'll give an example of this in real life in a short moment. Slicing. Slicing is just what it says. You can slice out chunks of text from a text string and process that separately from the entire string. And so we have the example here of a string we've called the string spam. So if you slice it from position 1 to position 3, then you get PA. So if S is a 0, 1 is P, 2 is A, and 3 is M. Notice that it is inclusive on the left side, so number 1 position, or index 1, is given to you. The right number, number 3 over here on the other side of the colon, is exclusive. It is not included in the value that is returned. If you do not provide a right-hand number on the column, then it says whatever value that you gave me on the left index, so in this case 1, all the way to the end of the word. So it's going to give us PA and M. Everything that is to the right of that initial index, index being 1, is P. If you're going backwards, then you can start at -1, which is... If you're going backwards and say you want to start at the very last number and go forwards in the word, then you put nothing as your first value, colon, and then where you want to end, so -1. So again, it's going to start at the initial value, so 0, and it's going to be inclusive to every number except what's on the right hand side. So it will not give you the M, which is in the last position, because you've told it that you want to go there. And then this next part is just telling what I've or reiterating what I already said about being inclusive on the left, exclusive on the right. So we will jump back over into our example, And you'll see right here that I went ahead and demonstrated going backwards, and if you tell it string :-1, it gives you everything up to that last value. If you want to know how long a string is, you can use the keyword lane for length, and then string, or whatever variable name you gave it, and it will tell you how many characters are in that string. So from there, you know that you have 4 characters to work with, which are going to be index of positions 0, 1, 2, and 3. So if I say give me string position 0, it should give me an S. If I say give me string position 3, then it gives me the last value, M. And if you want to slice it, then you can do that too. String from index 1 to index position 2 only gives me the P. Inclusive on the left, SPAM, P. Exclusive on the right, don't give me anything further, so it's only going to give me that value. So basically saying string slice 1 to 2 is the same as saying string index position 1. Hope that makes sense. So moving on to string formatting, there's 2 ways to handle string formatting. Basically what string formatting is taking additional information, whether it's variables, whether it's the results of functions, or pretty much anything that comes as a Python object, and putting it into a string for either further processing or output to the screen, to another program, whatever the case may be. So the first method is what I call the legacy methods. It comes from Python 2. Primarily is where you're going to see it. Legacy code. Nowadays, most everybody has gone over to the new method, which is using a format call. So the old method, you would have to identify the parts of your string that you wanted for substitution. So if you wanted to put an integer into your string, you'd have to identify it as a %d for an integer. If you're putting an additional string into your result, then it would be %s to show where that string was going to be placed. The new method uses format function call. So you can have it by position, where you use curly braces to signify where those replacements are going to occur, and then at the end of your text string, after you've closed the quotes, you just use the format function call and you drop in whatever it is that you want. In this case, it would go left to right, spam, spam, spam. For numerical, it's similar to positional, except that you are putting a placeholder within those curly braces. So 0, 1, 2 is what I have here, and it goes 0, 1, 2. So just like we talked about indexing within a string, that's what you're doing with your format arguments. So chicken is position 0, beef is position 1, pork is position 2. So it would drop those in each of those one of those locations. But because you have now identified each of these arguments with an index number, you don't have to use those in the same position on your output. So if I wanted 2, 0, 1, I could do that and it would substitute appropriately within there. You can also reuse those numbers. So if I wanted to have 0, 1, 2, 0, 1, 2, 2, 1, 0, it would substitute all of those in correctly within that sentence. And similar to that is using a keyword associated with the value that you want to drop in. So instead of having to know the index number, you can just give it a name, color, and flavor, and then in your arguments you just define what the value is that is going to be associated with that keyword. Red is your color, it'll drop red here. Sweet is your flavor, and it drops sweet here, so you get red and sweet. Before I go into the examples, I just wanted to talk briefly about the legacy syntax for string formatting. Python 2 has common string operations, and part of that is string formatting. And it gives you everything that you need to do, alignment, basically how do you want your output to appear. So you can set up columns, you can set up left justification, right justification, things like that. And then down here is where your substitution, the percent number or the percent value comes from. And then it even goes through and it gives you some examples of how it's going to be handled within your code. Here's your keyword arguments, so latitude, longitude, and it's just going to substitute those in as it shows right here. And so there's a lot more information in here. It's very complex. It's not easy to remember unless you're doing this a lot. So this is, if you're working with legacy code, this is a very useful site to bookmark so you can come back to it quickly. So if we come back over to our interactive session, so we're running IPython again, this shows you how that legacy format works. Now, this legacy formatting is available for Python 3. You can still use it. It's just more common in Python 2. So here we're just printing out a string and we are dropping in an integer and substituting in a string. The integer is the number 5 and the string is died. You go ahead and you print that and it says this is the 5th parrot that has died. So all we're doing is literally just substituting whatever we put over here as arguments into their respective positions here. Now, these are positional, so if you forget, if you have a lot of substitutions and you forget where you are putting those arguments, you can get output that is not correct because you're missing a argument or you have too many and you get an error. Moving on, we're doing the same thing except we are using our positional formatting with the curly braces. So instead of having a %D and a %S, we're just using empty curly braces as the locations to substitute our values. So we're still having 5, we're still having the text string died, but they're just being dropped in positionally based off of those two values, and you see it comes out the exact same. Now, numerical formatting, we have a 0 and a 1 in here, and they are associated with a 0 index and a 1 index, and they come out just as you would expect them to in this case. If we reverse the numbers, so we have a 1 as the first and a 0 second, then it basically just gets our position 0 and our position 1 values and just drops those into those locations. Eric the leader orchestra instead of Eric the orchestra leader. This makes it a little bit easier when doing your arguments, because you can more readily count your index positions as you're adding your arguments, especially if you have a lot of arguments, rather than trying to count how many empty curly braces you have and then try to match it up with its position. As long as you're going through what the output should be, you know what the number is going to be, and it's much easier for you to keep track of those positions in your arguments rather than counting every single time. So in the next example, we're just showing keyword association. So we, instead of using numbers, are using words, and then we associate a value with those keywords. So num is 4, walk is silly, and then you go ahead and you print that out and you get 4th minister of silly walks. Very easy. This is my preferred way of doing it, because then there's no forgetting of how many empty spaces you have, how many index values you have to match up over here. It's all just based off of keyword. The only time I really just leave it blank is if I have maybe 2 or 3 variables that are going to be substituted in. If it's more than that, then I'm probably just going to go ahead and assign some sort of a key value to them rather than trying to count them all out. So now we're going to talk about what's probably the coolest string formatting method that Python provides, and this is called f-strings. So this eliminates the use of the format call completely, and you end up just using a f at the start of the string that's going to be printed out, and then you use the curly braces like you normally would, but you don't have to worry about providing the dot format and then all of the arguments. The arguments come from previously defined variables or function returns or things like that. So this is very helpful and useful for shrinking the amount of extraneous code that might be in your program. So in this case, we've gone ahead and we've defined 3 variables. 2 of them are text strings, 1 is an integer, and we use an f string right here. Just like we have previously, we're using keywords which match the variables that we've defined. The only thing that's different now is that we're just putting the f signifying string format at the beginning, and that goes in and it processes this and substitutes the values that we've assigned to the variables into the output. Something else that is cool using f strings is that it's not just assigning predefined variables. You can actually do operations within the curly braces. So in this case, we are doing a arithmetic calculation within the f strings. We are subtracting 1 from 3, and as part of the processing of that text string, it gives us what the result is. So again, this is another way that you can kind of shrink the amount of code that you have laying around by combining some of those operations within the f string curly braces. Going along with that, we can predefine a function such as we've done up here, to uppercase, take your text, convert it to uppercase, and then use that as a function call within the f string. So in here we've got the f string defined as a regular text string, and we are doing a function call to uppercase up here, and then the argument that is being passed as text to this function is the string I'm hungry. So what ultimately happens is the text string is processed, everything is processed normally, it gets to the function call, it takes the argument that is going to the function, passes that to the function, and then returns it as uppercase. So there's a lot of functionality that you can get out of f strings, and this is really the best way to work with text strings within your code, unless you have a reason to use something else. We're going to finish up with joins and splits for text strings. So these are 2 methods that are inherently part of strings. Join is similar to concatenation, where you are combining 2 text strings together, but instead of string 1 plus string 2, you are taking one of those strings and joining it to the other string sequentially. And so I'll give you an example of what that means. It does not make as much sense as you would think until you figure it out. Split separates your text string by default using white space. So if you have a space between words within a sentence, it will return a list of those individual words rather than giving you that sentence back. But you can change what that separation character is. So it's normally a space character, but you can also use commas, hyphens, whatever the case may be. So this is an example of what I meant by string joins don't work the way you think they do initially. So if you wanted to join these two strings, I am and you are, and you do that using the proper method, it comes out as basically gibberish. What's actually happening, once you take a look at it, it does kind of make sense. And considering the fact that it's normally used to combine a sentence or a list of text objects with another character, which I'll give in the next example, then it makes a lot more sense as to what the purpose is. But basically what's happening is we are taking string 2 as the argument to join. The first character of that is passed out. So here's our Y coming from here. And then it's combining it with whatever string 1 is, I am. So here is the entire join for our first character, Y. You'll see that the next character, O, in you, is there, and then we have O, I am, and then the U is right here, U, I am. There's a space, so there's a space right here, and then I am, so on and so forth. So basically, we are iterating sequentially through each character that's in string 2 and combining it with everything that's in string 1. So this next example shows what is more common to happen. You give it a character, usually a dash, a comma, a slash, whatever the case may be, and then you join a text string with it. And then it goes through and it combines the first character with our symbol right here, and then it does it for the next one, and then the next, and then the next, and so on. And so it's an easy way to format a text string if you need to have commas, spaces, whatever it is that you need. This is one way to do it. So this is what a join is most commonly used for. So a split takes your sentence and then, like I said, default splits it on the white space, so the blank space between words. So here it's just returning a list of each of the individual words that's in that sentence. We'll talk about this in depth later, but this is one version of tokenization where a object, in this case a text string, is tokenized into its individual parts, and each of these parts, in this case words, would be a individual token. I said you could change what that default character is going to be on the separation. So in this case we have used a comma as the separator. So it will go through and it will parse this text string and give us all of the individual words from there. Notice that since we only put a comma in here, it's going to include the space at the beginning of each word. So it's going to separate at the comma, and then whatever's after that is part of that next token. So here's the comma, and so it's going to take this space and the next word. Here's a comma, so it's going to take the next space and word, and finally for the last comma, the final space and word, and it's going to return those. So that's just showing you that when you are splitting a text string, you need to be aware of how that is going to be returned to you as a list object. If you don't want these extra spaces there, then you would have to go in and tell it to add a space after the comma. And if you do that, then you get the words without that leading space on it. So that's it for this video. We talked about how white space matters in code, proper indentation of your code blocks. We'll cover that in more detail as we go along and see more code. We looked at some of the numbers and the types of numbers that are available within Python, and then we looked at text strings and a lot of their functionality and things that you can do with them just using the built-in tools that come with Python. In the next video, we're going to continue our dive into data types, looking at lists, dictionaries, and just a lot more of the built-in tools that Python provides for you. I hope you enjoyed this video. I hope you learned a lot, or at least some, and I hope to see you in the next video. Until next time, have fun and keep learning. Thanks.